All right, good afternoon, folks. Thank you for joining us. We have one more session in this room, and then our last session will move back to the big text. So it's my pleasure to introduce Francesco Iorio and Kyle Sponseller, who will be presenting on how is AI disrupting the AEC workplace and how will we deliver projects in the future. So round of applause for our speakers.
Yeah, thanks. All right, thanks for sticking out. Thank you for sticking out in the last session of the day, right? So appreciate actually the effort. Okay, quick round of introductions. So I'm Francesco. I'm the CEO at Augmenta. We're a startup from Toronto working on AI agents for construction design and engineering. And Kyle, if you...
I'm Kyle. I'm president of CNR Electric and principal of KTS Engineering Group. They're sister companies. I'll introduce them a little bit more later.
And yeah, so today we're here to actually just kind of quickly tell you, some perspectives on kind of what we're seeing kind of coming up, right? So part of it is something that we're working on ourselves. Part of it is the partnerships that we have, right? So, but kind of generally speaking, the fundamental reason that we're here, right? So as Atul actually mentioned earlier in the day, right? So are quite substantial, right? So there's an economical kind of responsibility to the construction businesses, right? So that permeates the GDP of the entire planet, right? So there is an environmental responsibility that we understand, and again, we've seen also kind of how these actually interact and interplay with each other, right? So actually, it doesn't have to be the case that something that is better for sustainability is worse for the economy. Again, operations of buildings is one such case, right? So where a building that is higher performance is also, like greener for the environment, actually, generally speaking. And then, of course, kind of socially, it's a challenge as well, right? So as we know, not only, the population is growing, right? So demands on kind of housing and especially kind of large overpopulations of cities, right? So, but on the other hand, again, there's the challenges that are presented kind of daily in terms of workforce, right? So where there's not enough, kind of cycle. The new, breed is coming in at a kind of slower pace than ever before, right? So, and people are retiring at an accelerated pace actually from the workforce and are not getting replaced actually as fast. So one of the challenges that we see that is really kind of fundamental to what we're seeing in the industry, right? So is this concept of design and engineering being very siloed, right? So and kind of over the decades, people have kind of abdicated progressive responsibility, starting from the architects, no blame actually assigned, but the project's complexity has grown to a point where a single individual cannot really have the vast knowledge necessary to understand all the building codes and regulations, especially for given that every kind of municipality can have its own, right? So and so there's a necessity to actually spread out and delegate actual responsibility to a number of individuals and organizations, right? So but this process of combined kind of coordinated design, right? So is still completely manual. Kind of BIM was supposed to be one of the avenues or that could fix or at least kind of ameliorate actually some of that, right? So but it kind of didn't make that large of a step that people actually foresaw, at least when they started introducing the concept of building information modeling. And part of the reason is also because, to be honest, the software that exists today, that is state of the art, is starting to be close to 30 years old, which is from a different era in terms of compute, right? So AI didn't exist actually back then, or not in the shape that we think of it today. The cloud actually didn't exist back then, right? So it's actually a very different way of even conceiving and creating actually software at that time. And so the result is what you all know, right? So better than me, I come from computer science, so I've come to the construction industry only the last 10 years, 10, 15 years, right? So, but I've actually had the privilege to see from the outside and then from the inside actually the evolution, right? So, but this is a result, right? So there's a lot that is spent on kind of waste and rework, right? So that shouldn't necessarily kind of be the case, right? So, and so what we think that truly can make a substantial difference, that is something that is not quite as understood today, right? So is the application of artificial intelligence actually in the design and engineering of vertical construction, horizontal, but especially vertical construction. As you know, the complexity is such that the design and coordination of all the systems, all the parts, all the logistics that are involved in a construction projects as they grow in size and complexity is very hard, right? So, and the industry is actually starting to adopt or to consider solutions that go from scheduling management, contracts management, et cetera, right? So those are, let's say, the low-hanging fruits of tools like large language models, right? So, but there's more, right? So the AI can actually start to contribute more in the process of designing, the process of engineering, right? So and this is actually something that we think actually sits at a nexus that can unlock value, upstream and downstream of the actual act of design itself. So the challenge, though, is that, as you may or may not know, right, so creating artificial intelligence that works in engineering, right, or in design is just very hard, right? So, and there's a discrepancy also between the affordances that it gives and the allowance of people available out there, right? So again, I just say that anyone can drive a car, right? So as in, it's something that is exceedingly hard for AI to do. But at the same time, you can find anyone on the street that can learn to drive a car in no time, right? So, but designing a building, architecting a building, designing the structure, understanding the calculations, the code, all the regulations, and everything that is unwritten that kind of sits not in a book, right? So, but in people's minds that have worked in the industry for 30 years, right, or more, right? So, it's very, very difficult, right? So. And so it takes years. It takes years, right? So to train an appropriate engineer or a designer, a BIM designer. So there's this challenge, right? So of actually finding, retaining, and kind of upbringing enough people, skilled personnel to do this properly, right? So to actually leverage kind of BIM and actually virtual design and construction, right? So to the fullest, right? So, and so this is what we're trying to change, right? So, and again, there's a path towards a future where this is different, right? So and we just want kind of together to show you that it's not as far into the future as it may seem, right? So, but it's something that we can offer you at least a first glimpse of today, right? So we've been working on this actually for a long time. It's been kind of hard to actually put together, right? So from scratch, right? So, but the first kind of glimpse is this electrical agent, right? So, which is a system, is an artificial intelligence that draws BIM for electrical design, right? And again, I just want to show you just quickly on, in principle, right? So why this is a different way of approaching BIM kind of altogether, right? So it's a true generative system in the sense that it is not a co-pilot or an assistant like Google Maps, right? So where you pick point A and point B and it just does the work, right? So, or it makes a recommendation on route, right? So it's something that where we have managed to embed the knowledge, the construction knowledge, right? So it's something that truly enhances the abilities of people that work in this trade, right? So it's something that actually performs some work on your behalf. It's not a shortcut, right? It's not a workflow automation, right? So it's the type of AI that is similar to the one that you would use to, draw a nice, beautiful picture or create a video these days, right? So, or on the other hand, write a poem, right? But to do engineering work, again, it's a different class and different generation. And again, if you follow the AI world, if you will, you'll notice that there aren't that many of those, right? So, and the reason that is, again, it's just very, very difficult to actually create an AI that works at that level of precision, if you will. So during this journey, actually, we're very lucky to meet, actually, in our journey to essentially to bring this technology actually to market and to adoption. We're very, very lucky to meet CNR, right? So. CNR is extremely progressive and future thinking, right? And then Kyle is going to explain kind of how we jointly approached essentially a traditional problem, right? So creating and deploying BIM modeling actually for the construction of a project, right? So and how that actually was the perfect opportunity to actually bring this to life, right? So and to actually use it in the field for the first time, right? So for the first time ever. So, Kyle, I'll leave it to you to introduce yourself more and CNR.
Yeah, so we're a full-service electrical contractor at CNR Electric. We teamed up with Augmenta and, went out to solve some of our problems. We do everything because we're in the cornfields of Michigan. So we will go from anywhere from doing a residential complex to doing, you know, a $5 to $10 million hospital and anywhere in between. We used Augmenta on a K through 12 or K through 5 school. If you want to skip ahead here.
Yeah.
So this is Mount Hope. So at our shop, we've set out to solve one of our issues that everybody faces in construction. How do you get a project out faster, more accurate, and more data enriched? And how do you solve the supply chain issues when it comes to just, you know, procuring just certain hard to find items? So in this process, this is we're using Augmenta here. We will go through, our BIM guy will lay out all of our starting points for all of our switch gear, and then we end up placing all of our endpoints. And then we push it into the cloud, and the cloud processes. It spits us back about 10 complete simulations for AI. We kind of look at it, see how good we did, what's our percentages, make some alterations, and then eventually we get to a product that we can export out. You want to go to the next slide. And once we get it exported out, we can actually take the time to finish it and make it into fabrication. So what this actually allows us is the BIM guy can drink coffee or, you know, run it at night. So it cut our BIM time down by about 15%. Now, mind you, our BIM is fabrication level. So every conduit in the electrical system is modeled. And not only is it modeled, it has all of the data in it. It has all the circuitry, where it's going, where it's starting, and where it's ending. Also, which I kind of got ahead of myself, the ability to compare multiple solutions at the same time. So once we get it done, we can look at it as a high level and see how many feet of conduit, how many bends, you know, what's the most effective form, and what meets the design criteria. So this school in particular was a challenge because all of the classrooms were large timber mass, and they wouldn't let us do anything outside of the corridor. And obviously schools don't like to give up a lot of room in corridors, so all the MEP systems were really tight. It also is important to note that AI doesn't just work on BIM projects. So we actually didn't BIM coordinate this project. We pushed it through AI, went out and scanned the project during the MEP installation phase, and then went back and did some manipulations to the project. Jump to the next slide.
The level of sophistication that we have is miles ahead of anyone that I've heard of doing something, anything like this.
We used ACP to run all of our conduit, and the guys are down here now on site installing all of it. Augmenta is going to be the piece that, instead of spending hundreds of hours drawing conduit down corridors, it's going to generate your paths for you. So it's just the next logical step to get fabrication out the door faster and hopefully more accurately.
Everything that's on these pipes, like the labels and whatnot, the circuits, is all populated and put into place by the ACP.
Oh, wow. It gives us a competitive advantage. We know the entire infrastructure.
It's doing it for you. It's very simple to use.
Yeah, sorry for the plug, but it was really to show kind of what the process actually kind of went through, right? So that kind of start to end, right? So it's a very different way of approaching projects this way, right?
So to implement Augmenta, it wasn't as big of a lift as one would imagine, because most people who are going to do electrical BIM or any BIM will start with pulling out the data from schedules. So you can kind of see it here behind. There's a feeder schedule here that we essentially populate to tell it where we want everything to go. So the Excel sheet already existed, and then it was as simple as pushing up the architectural model that the architect provided to us to get it started off the ground. So this is kind of the other piece that you saw in this video. So this is what do you do after you get AI, and where is the future of construction going, right? So this conduit here is all drafted by AI. And we went through and cleaned up some of the pieces that we needed. But this is a software that will allow you to pull a BIM model and pull it down to the CNC equipment that you guys saw in that video. So right now, whatever Augmenta draws in the cloud, after we clean it up, we can pull it down and push it to saws and run it through printers that allow us to print all the data that Augmenta puts into the model for the end user. So now, at any place in this location of this project, Mount Hope's maintenance people, or Lansing School District's maintenance people, can just look up, and within 10 feet, there's always going to be a label that tells you what's the system, what's the conduit circuits, and where is it from and where is it going. Also, it's important to note that the conduit maintains the same name all the way through. So if you find a lighting conduit that's C4 and you're on the opposite side of the building and it's C4, you still know it's the same one. It's connected somewhere along the way. Jump to the next one. So then, the other thing about Revit and AI is, the data is obviously very valuable, but you still have to be able to use it somehow. So Allied will go through and post-process the conduit. So this is just native Revit conduit that was drawn by AI, and we are basically post-processing it. So this kick 90 that I happen to click, says that you need to put a 5-degree bend at 58 1/8, and then a 90-degree bend at 32 9/16. And then we can take that and push it through the printers, and the printers will actually print the mark exactly where they belong. Keep going. So basically what happens is when we started doing this, we did a college that was about 60,000 square feet, and it took us about 1,600 man hours to actually draw all the conduit. And we didn't have near the, I think that's echoing, is it? We didn't have near the data-enriched models that we currently have today. This Mount Hope, with using Augmenta to run the bases of the conduit and just cleaning it up, we have about 250 man hours, and it's roughly the same amount of square footage. Anything else you want to expand on that?
No, I mean, again, the point really, right, so is that it is not only the process of automation that is important, right? So the data that is generated is then available downstream to run all sorts of additional, benefits, right? So again, from prefabrication to operations, right? So and maintenance. That is actually key because generally in a regular BIM process, that is extra time that people, most of the time kind of skip to actually get the models out, as quickly as possible actually to the field, right? So, whereas again, the addition of artificial intelligence not only provides a way to kind of shorten the process, right? So, but again, it enriches the data in ways that normally it just wasn't done, right? So for lack of time. And again, to what Kyle was mentioning, right? So it also, like this kind of shortening of the design time and the optionality allows people to all of a sudden run what-if scenarios, right? So engineers and contractors are now starting to use artificial intelligence to understand, like, given particular floor plan, there may be 4 or 5 different options for the location of an electrical room, right? For example, right? So, and under normal circumstances, no one has the budget to ask an engineering team to figure out all the pathways and all down to the level of detail of constructability, right? So what all these 4 or 5 options actually would look like in terms of how does it actually stack up for maintenance or for accessibility or for like total cost of construction or labor time, right? So whereas all of a sudden you have this ability that allows people to actually do a better job, not just kind of faster, if you will, right? But it helps actually people to provide extra value, if you will, to their own kind of customers kind of over time, right? So
yeah, gives it a lot more information for the end user to help maintain their building. Also, we've all been in BIM meetings where we get pretty decent mechanical and plumbing models from the engineers if they've used Revit, right? Electrical starts with nothing. There's no conduit, no branch, anything. If we're lucky, we might get some feeders from the engineer. So this helps us bridge that gap and speeds it up and lowers the cost of putting all the conduit in.
It's also interesting actually for us that, again, it's kind of one of the mantras, if you will, right? So that the first building that was ever produced with the output of an AI, right? So, or at least the help of an AI, it's a public elementary school, right? So it's not a luxury tower in the Emirates, right? So it's kind of, it warms my heart that this is the true path of democratization, right? So it's not actually something that should be reserved for the haves, right? So, but it's something that is meant, everyone or all buildings to be designed, as quickly and as high performance as possible, right? So that's really kind of that's the goal. And this is just a start, right? So it's just the tip of the iceberg, right? So that's kind of part of the message, right? So this is regardless of whether you may be a fan of Augmenta now or ever, right? So or CNR, right? So but it's technology that is coming, and that's really kind of the message that we wanted to convey, right? So the electrical system is a great start, as Kyle was mentioning, because generally is kind of neglected by the engineers when they produce initial drawings, right? So we collectively thought that speeding up that particular process would have the best bang for the buck, if you will, right? So if we had to kind of pick a trade, right? So, but the foundational technology that allows us and maybe others, right? So to advance, more kind of towards full buildings, right? So is nascent, but it's coming. Like, as this is not as far away as people actually may imagine, right? So we want people to, be aware, right? So to understand that is not kind of far-fetched. It's something that, again, it's coming in the next few years, right? So, and it'll be kind of more and more pervasive, just as a byproduct of the skill shortage that we all see, right? So, and the desire for always increasing complexity, right? In the few months that have passed kind of between this project and now, right? So we've been able to run, data centers, right? So there's like miles and miles of electrical raceways that are generated by AI, right? So it, even the capability and the level of quality, so the precision of the output is kind of constantly growing, right? So as it learns kind of more, right? So, but it can be reached at least a level of threshold of being usable kind of today. So again, this is just crucially, it's not a warning for people, for anyone, that they're going to lose their jobs, right? So it's actually quite the opposite. There aren't enough people who want to do this for a living, and this is to kind of shore up the fact that at the same time there's this crazy demand for construction and for precision, right? So for through having lower risks, right? So, and so that's the crucial aspect that we're taking, right? So in conclusion, right, so this is really kind of the direction that this is taking, right? And we wanted, again, everyone actually to be aware. What we really believe is that AI is poised to become a companion to everyone actually in the construction industry, from insurance brokers all the way down to building maintenance and operations, right? So, and everyone in between. It's not a type of technology that will determine a zero-sum game, that will perpetuate the zero-sum game. Right? So the affordances and the availability of extra benefits, right? So from not just economic, as I said, right? So, but for example, schedule compression, right? So is something that will be available to all the stakeholders, right? So there's no one actually specifically winning, right? So, and again, the point is that, as Atul was actually saying this morning, right? So one of the critical components that we want to also make sure that everyone understands is that AI understands now, at least, what kind of real parts and pieces actually mean, right? So computer-aided design for 50 years has been mostly about drawing lines, right? So certainly drafting has been like that for forever, right? So, and so you have as a consequence a whole generation or several generations of tools, right? So that allow you to do anything, but 99% of what they allow you to do cannot be made, right? So you can draw it, right? So, but it doesn't necessarily mean that it's something you can build, right? So, whereas artificial intelligence is starting to understand the actual how things fit together and why, right? So, and so that means that, in perspective, the supply chain is actually going to become a first-class citizen and not only a afterthought, right? So as in, let's value engineer the hell out of it at the last second, and then demand that the suppliers actually, show up with the parts, 2 days later in the field, right? So this is something that can incorporate information, like real-time information about costs, about availability, about suppliers, right? So, and design according to them. Or giving you the affordance of changing even the design according to availability as essentially information kind of flows in over time, right? So again, it's a very different way of approaching a project, right? So, and approaching essentially your relationship with suppliers, right? So,
Yeah, construction's not getting any simpler. Buildings are getting more connected. We're putting more and more systems in. They're getting more sophisticated. You know, human nature keeps pushing the boundaries of innovation and what we can do. Buildings are getting taller. I mean, AI is just the next step. It's not going to replace anybody. It's just a tool that is there to really help accelerate the teams that we have.
that's it. Ultimately, it's about having better information, right? So as again, a tool was actually mentioned this morning, right? Insight is what's the most powerful, right? So it's the most powerful type of information that you can get, right? So, and AI in this particular new type of workplace, if you will, is something that will be able to provide a level of insight that is unprecedented much earlier in the process, right? So where stakeholders can essentially have a honest dialogue among between each other and with the AI as to what is the requirement, what's the fundamental goals, what are the fundamental characteristics they are facing or they're actually requiring for a particular project, right? So, and understand the consequences of those requests, right? So much more quickly than ever before, and so make those decisions in a much more informed way, right? So I'm always curious about a particular statistic where I've read actually on a paper, right? So that the vast majority of health hazards, of accidents, actually in the job place, or actually on construction sites, comes from rework. It comes from when people actually have to tear down and redo something they've already installed, right? So because they're paying less attention, right? So again, having something that allows you to have a much more precise, much more controlled avenue from digital to real, right? So again, has even like side unintended but very positive consequences, right? So it's not just for the economy of it, right? So not even just for the environment. There's just so much that, in our opinion, hinges on having the best possible design, the best possible information, right? So we believe that AI is the only, let's say, new method, new model, if you will, that will afford to have that design as precise as possible and in the shortest amount of time possible. So that is all we have for today. Really, really appreciate actually you again sticking around until the bitter end. So thank you.
Thank you. Any questions?
If you have questions, very happy to answer, of course.
So you said that in your workflow, you held off until you could get a laser scan of the building. Was that during the install of the mechanical and the plumbing?
Yes.
And y'all were able to sit out the BIM coordination process and still make up that time for manufacturing utilizing this software?
Yeah, absolutely.
Yeah.
So it's between Augmenta and Allied BIM.
That's right.
So Allied BIM runs CNC equipment. So what used to take my prefab shop 2 to 3 weeks, we can pump out in an afternoon now. We are literally pushing through automated saws that are pulling data directly from Revit, printing, cutting, putting it in a CNC tube bender, bending it. We don't have to pull tape measures anymore. So the strut shows right where the conduit goes. The conduit goes knows where the strut goes. There's marks. You line it up. You ship it out to site. So yes, we can. That's one of the big advantages.
That's very impressive, and I think you probably saved more than 15% modeling time.
Yeah, we definitely probably did. Trying to be humble.
So I don't know, there's a slide where you showed a graph. I don't know if we can go back. Oh, right there. What's, so it says, in use, obviously you showed us foundational technology and then the future. What's kind of stopping it from going further? Why haven't we seen it being used more yet in the structural, plumbing, mechanical, et cetera?
Oh, sure. I mean, they say that the way we approached it was actually trying to start from the hardest part. We wanted to take an approach that we would be safe in scaling, right? And so it turns out that from a regulatory compliance and the depth of nuances of the construction code, electrical systems, both from code compliance and from the nature of the geometric nature of raceway systems, is the hardest to do, right? So again, nothing against the complexity of structural engineering, right? So an HVAC, by all means, extremely complex of their own, right? So, but electrical is kind of a perfect storm, right? So we started there specifically to understand what technology approach, really, what AI methodology would work that would then kind of be reusable and scalable actually to a whole building, right? So that's the reason. So, and it took us 4.5 years to make it work in electrical, right? So now that we crossed the threshold, if you will, right? So we are now essentially applying it progressively to the other disciplines, right? So essentially we're trying to both actually move again on the axis of the scope, if you will, right? So, and in the level of abstraction, right? So the vertical axis, let's say, is a level of abstraction, the level of abstraction of the requirements, if you will, right? So we're going as fast as possible, and now that we are showing that it's possible, we fully expect competitors to exist and to come after us and the market, right? So, but once again, I think that we strongly believe that it is so necessary for the industry to move to the next level, right? So that we welcome obviously everyone else actually who can do this or can push us to actually work harder and to do it faster, right? So, but there is just limits in literally the complexity of the problem at hand that prevents actually us from moving that much faster. I mean, it took Google DeepMind many years to actually have a system that produces a protein, right? So that designs a DNA strand, small DNA strand. So it is interesting how again. AI can now be extremely creative from a perspective of, again, writing like a beautiful song, but for hard engineering, for precision, right? So it's much harder to do. So.
Any other questions? I guess I'll ask one more, and then maybe we'll head over to the big techs. What was the biggest barriers for you in the last 4.5 years, and then for you when working with the trades and the folks in the field, what was kind of the biggest barrier learning curve to get them on board and agreeing with it outside of the fact that you're the president?
So it wasn't really that hard of a barrier, right? Because the guys out in the field really don't know that AI did it. So the BIM guys were more concerned that they were going to lose their job. And I was like, yeah, but everybody in this room is working 60 hours a week. Wouldn't you like to work 40 and still make the same amount of money? So that pretty much sold the whole thing. It wasn't really that hard.
Yeah, no, that's, again, it's no coincidence that we named the whole company Augmenta, right? So then, we're very conscious of the fact that there's no replacement here, right? It's really not about that. The shortage is so severe, right? And going forward, that won't be a problem. In terms of what was the hardest challenge actually for us, the problem has been to combine in a single AI the, let's say, prescriptive knowledge that comes from reading books, reading rule books, code, right? So, and at the same time, discovering best practices from unwritten rules. So from analyzing models, analyzing how people actually do designs actually themselves, that is something that they don't necessarily kind of even study at school, right? So it's something that only manifests itself when they actually build things, right? So, or design things, right? So the combination of these two things has been from a technology perspective, has been the most challenging.
Thank you.
Of course.
One application that is really brought up by Atul's presentation this morning is basically saying we could build our business on building data centers. So the question has to be asked is, how does this apply to strut? And the light gauge structural strut that holds all these data racks, server racks up. And the complication of modeling that usually falls on the GCs. called scope gap modeling. And so I wonder where that exists in the timeline of applying AI design.
That's a great question. So again, like we are aiming to work on structural. So I mean, and again, structural is we'll need some level of guidance, right? So as in, again, we've dedicated the whole company to vertical construction right now, right? So we are already working on data centers, right? So but we're doing the electrical kind of side, right? So interestingly enough, from a pure computational perspective, the structure is much simpler, much simpler, right? So if we were to see the strongest case to work on that first, right, or to partner with someone that kind of pushes us in that direction, right? So it's something that we would definitely consider, right? So right now, MEP is, let's say, more than 50% of the cost of a building on average, let alone data centers, right? Data centers, of course, the GPUs alone are, billions of dollars, right? So, but on average on buildings, right? So MEP is what takes the most time actually to design and coordinate, right? So, and so our current trajectory is to create a group of agents that design coordinated systems by default, right? So our immediate goal for the next year and a half is to eliminate coordination, right? So to remove coordination altogether for MEP, for essentially for all engineered systems. We want essentially our ambition, right? Our goal, but we're always halfway there, if you will, is for the trades that collaborate to the same project to have a single generation button that does all. That essentially, whoever presses it, it always makes the entire MEP design, right? So for all, right? So if you need to move a column, it'll remake the entire MEP system. If you need to change the flow rate from a room, right? So it'll actually do a better job at ensuring that the flow rate actually is what you want, et cetera, et cetera. So, but in a way that is coordinated by default, right?
I love the idea. It's amazing. As a journeyman carpenter, I fail to realize the value when you have somebody install something wrong. So my question would be is how does AI design get applied to the installed product? Let's say a mechanical system gets installed, it's 2 inches off where it needs to be installed. That impact across all those MEP systems will require a redesign and negate the benefit of all the prefabrication you might have done. So how does this address that, or how can it address that?
That's a really great question. So again, I think that a partial answer, at least, is that if it's too late, at the very least, the AI can tell you what to do that costs the least to get away with it. You know what I mean? Like, as in, rather than just hacking it, right? So at least you should be able to actually get a recommendation as like, oops, what now, right? So, and it should tell you how to, get around it, if you will, in a way that is efficient. So that considers all the consequences, right? So as in, you may be at such an edge where if you install something like really wrong, it may change the length of a wire enough that by rules, it needs to actually size it up, right? So as in all of those consequences, but AI knowing the process and the rules and regulations, at least you'll know, right? So you'll know essentially the consequences of that mistake, if you will, right? So
not to interrupt you, but
no, not at all.
So the nice thing about AI is that when someone puts the duct in 2 inches across, it doesn't delay the project by 3 weeks, right? We move the duct 2 inches over, push it back through. Tomorrow morning, we have solutions. And the nice thing that we've learned in fabrication at CNR Electric and KTS is that there's no such thing as the whole run is abandoned, right? Yeah. So if that duct got moved 2 inches, all we did is abandon a transition piece, and maybe we had to throw away our corner piece of conduit and rebuild it and ship it to site. So, my other argument always is that if you're arguing more than about 6 inches of space, you need to make your building bigger. But no one listens to me.
No, but I mean, the whole point really of having designs that are as precise, like as close as built as possible, right? So is that too, right? So as in, ideally everyone would install everything with the total station. Ideally everyone, but you need to have the data to do it, right? So you need to know exactly what to put where, right? So having the instructions, having checks, right? So AI can actually eventually, right? So on the construction site, can actually take another pair of eyes and say, like, you know what, that's wrong, that's not, just move it over there, right?
Can't stress enough the importance of shared control points. That's the other thing. When someone's off 2 inches, let's hope everybody's off together.
Fair. Yes, yes.
Yeah, I remember seeing a similar automated conduit modeling tool several years ago, and one of the issues at that point was, the AI could find the quickest route for the conduit, but obviously in construction we're racking a lot of that together, and it had challenges with understanding the racking systems. How have you solved that problem?
That's a great question. That's literally kind of what I was alluding to earlier, right? So essentially for us, creating a kind of Google Maps kind of here to there, right? So a router is trivial, right? So the challenge was to make the system understand like reasonable decisions, like as in the system understands normally, right? So that if there's a corridor right there where it's likely that all the other utilities are going to go through, you shouldn't probably plow through those 15 rooms, right? So just because it's shorter, right? So because the system understands that penetration through a wall has a cost. The labor that is included into going through a blast-proof wall, right? So is not the same as going through polystyrene, right? So that's what I mean. Like as in the smart and the time that it took to actually take the system actually to the level it is today, right? So is to teach it that this is something that is common knowledge actually among practitioners, right? So but it's really not to an algorithm, right? So and embedding into the system enough like trade really expertise, right? So was what it took so long, right? So and also we believe why everyone else failed before. Yes, we're not the first one to attempt actually something like this, right? So, but yeah, talking to the folks actually on the trade, like CNR and other customers, right? So you can tell that this is a system that has another perspective, if you will, right? So it's not just trying to go A to B shortest, right? So there's all sorts of consideration that it has to make in order to make it actually constructible and actually viable. Well,
yeah, that's where the relationship between CNR and Augmenta became so strong. So when we first did it, we ran it on an existing building, and it did a great job, right? It ran the pipe as short as physically possible, but we made an argument that said just because the pipe is shorter doesn't mean it's more efficient. You get a lot of labor gains by banking conduit. So Mount Hope was the first one, and I would probably say we had 30 or 40% rework. And now we've moved on to another K through 5 at Willow. We've done 2 fire stations and an office building. And the system, we're feeding information back to Augmenta, and they're doing a really great job of understanding what we're doing. And the product that we're getting and actually having it run down the corridor instead of through every single firewall and we have to fire caulk it the whole way, right? We got better paths and better banking systems set up. And it's really understanding how we do it. And the more people who get on board with this and the more models we feed back to say this is how we really do it, the better the product's going to get.
So the challenge was actually get it over that first threshold, right? So where it looked presentable, where it looked something that a foreman would say, I could start with this. Never mind, I'll install it verbatim, right? So, but I can start with this is hard enough. Believe me, it's
Okay, so Brandon's already headed over to Big Text, so just want to say thank you, Francesco and Kyle, for presenting. Could probably just keep listening to you guys. So, sorry we've got to cut you off, but we do all have to go over to Big Text now. So there's one more panel. I'll ask you guys to just go on inside, grab a seat. They may or may not have already started. So that'll be our last panel, and then we'll have a couple closing remarks, and we'll try to wrap everything up by 5. Thank you.
Thank you. Thanks, everybody. Thanks again.